Chapter 11, gases. So I think a lot of kids have tried this. You put a bunch of straws together and make a really long drinking straw. How long is too long? Could you make an infinitely long straw and have it work? Turns out you can't. And have you ever thought about what's happening when you're sucking on a straw? Why does the liquid come up? Liquids don't naturally just come up, right? When you're sucking on a straw, initially there's air in here, right? And you're sucking and you're removing the air, and that creates a lower pressure situation. And the soda is actually pushed up into the straw by the atmospheric pressure that is pressing down on it. Not an obvious thing. Now, if you're just hooking straws together, obviously you're going to not have perfect seals. But even if you had a perfect seal on your straw and you made it longer and longer and longer, and you could make a perfect vacuum, meaning you could suck infinitely hard and the straw wouldn't collapse, you still couldn't get a straw to work that was more than about 10.3 meters. That's 34 feet. That's a long straw. But you're not going to be able to suck liquid up a straw that's any longer than that. Why? Well, we're going to find that out. So we're going to learn about gases. So here's an illustration of gas molecules. Gases are just traveling in straight directions and they're bumping into things. And they exert a pressure. Pressure is the force exerted per unit area by the gas molecules as they collide with surfaces. So the pressure exerted by each gas molecule is really, really tiny, but there's a lot of them. And on Earth at sea level, the gas molecules in our atmosphere exert an average pressure of there it is in newtons per meter squared, but 14.7 pounds per square inch, which is PSI. So 14.7 pounds per square inch. You're like, well, I don't feel any pressure. Yeah, well, the fish that live really far down in the ocean don't feel pressure either because their bodies are designed to work with the pressure. We would not be comfortable if there was no pressure on us. You go into outer space and there's no atmospheric pressure, you're going to have some problems, aside from not having any oxygen to breathe. But our bodies are used to having this pressure from the outside. So here is a picture drinking orange soda. When the straw is just sitting in the orange soda, the level of the liquid inside the straw is going to be the same as the level of the liquid outside the straw, right? And the pressure of the atmosphere pushing down on this liquid is going to be the same outside the straw and inside the straw because it's open at this end. Now, if you suck on the straw and remove some of the air that's in the straw, you're lowering the pressure. And then the atmosphere is still pushing down on the orange soda, and it's going to push some of it up into the straw. And it will move up until the pressure inside the straw is equal to the pressure on the outside of the straw. And that's how a straw works. So if you had a perfect vacuum, so here, this is looks like a petri dish of orange soda, and here we have a long rigid tube, and we've got a vacuum pump, and we're actually able to pull a perfect vacuum, meaning we've sucked all the gas molecules out. There's nothing here. The level of the soda would only rise 10.3 meters, about 34 feet. Because at that point, the pressure of the atmosphere pushing down is going to equal the pressure. It can only raise this 10.3 meters because then the soda is pressing down as well by gravity, and so those pressures are going to be equal. It would rise up to 10.3 meters, and you can't get it to rise any farther. On our planet, yeah. If you go up in elevation where the atmospheric pressure is less, the column would be even lower.